La 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 la. La 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 la. La 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 la. La 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 la.
Well, here in this video, we would like to derive an equation for the potential drop across the balancing length of a potentiometer wire. So, to remind you back, how does a potentiometer looks like and what are the major parts of that? AB is a long wire which is divided into meter pieces and connected with the help of a copper strips. On top of that, there will be a primary circuit, a strong cell, a primary cell, a key to switch on and off, and a rheostat connected across this wire. So this cell, this EMF must be having some internal resistance. Let me call R as that internal resistance. This rheostat connected at a particular place will have some resistance that you call like resistance series, RS. This entire wire has also some resistance. Let me call that resistance as resistance R. So there are three resistors in the primary circuit. All are in series. What are they? Series resistance to the primary cell, rheostat resistance, which is a series resistance, resistance of this entire wire, that is R itself. So there are three resistors in the primary cell. The primary cell has an EMF E. So what is there in the secondary cell? If you look at the secondary cell, we connect a cell whose EMF we want to compare, E1. It is connected to a galvanometer and high resistance, of course, a jockey. We'll be keep on varying the position of this jockey till the galvanometer shows zero deflection. In that case, balancing length you call it like L1. We know the formula that at balancing length, potential drop across that wire is V equal to IR. So you need to be little careful to understand what is this I and what this R is. I is the current passing in wire, manganese wire. So this is what your I is. Be careful. What is this R? Be careful. This R is resistance of part of wire. Be careful, not the entire wire. Resistance of part of wire having a length of only L1, because you got a balancing length up to that L1 or L. So it has a resistance of, so be careful. So what is the resistance R is? This is the length L1. This piece is having some resistance, that is this R, right? So now what happens? So if you write the formula further, so yeah, what we can say, potential drop V is equal to total I in the wire. What is that I now? I in this wire is due to this primary circuit. So total EMF in that primary circuit by total resistance as per the Ohm's law. Total EMF in the primary circuit is E. Total resistance is, as I told you, there is a rheostat resistance, RS. There is an internal resistance of that cell, primary cell R. And there is a resistance of that wire. That wire R. Be careful. That's the total resistance. Right. Okay, this R, what are we writing here is the total resistance of the wire, because you are talking about the total resistance. So be careful, this R what we are writing is the total resistance of wire. That's the total current, right? We got an equation for the total current, this one, where RS is the series resistance because of rheostat, small r is the internal resistance of the cell, primary cell, capital R is the total resistance of manganese wire between the points A and B. This is the points A and B. This is the total resistance. R is the total resistance, like this. But this R, be careful, this is R is a part of only length L. That's I. Now I have to write what is the resistance of this part of the resistance. What is the resistance of this? I want to write now this part of the resistance. How can I get that resistance, right? Let's see little carefully. I know this total resistance. Be careful. This entire part has some resistance, right? So what we can say? Total resistance of the entire manganese wire is R. Total length of that wire, let it be capital L. Then resistance of wire per unit, per meter or per centimeter is R by L. Now you want resistance of the wire whose length is L1 or L, right? So that implies resistance of wire of balancing length L1 is resistance per unit length multiplied by the balancing length. That's what this RL is, right? Resistance of that wire where balancing length is found. Now I know the equation for I already. This is the equation for I. Now I know the equation for resistance. I can now write an equation for potential drop. That implies voltage drop across wire of balancing length is IR. What's I? This is the equation, right? This is the equation. Total EMF by total resistance. Series resistance. Let's restart. Internal resistance of the primary cell. Total resistance of the wire multiplied by resistance of that piece. R by L into L1 or L. This is the formula basing on which we can calculate the potential drop across the wire. So across this wire you have calculated V. This is that V, right? That's how we have to calculate. Thank you for watching.